All right, welcome to 10.7. We're going to be talking about vector functions. And so a vector function is a function of the form r of t equals vector f of t comma g of t comma h of t. And of course these letters are arbitrary, but the point is you have one variable and each component is a function of that variable. And so I want to go ahead and show you what these kinds of functions trace out. What do their graphs look like? And it's time to go back to when you were like 3. So we're going to do a little time travel here. And when you were 3 or 2 or whatever age that you went to the dentist for the first time, you might have played with something like this. And little did you know, all these years later, you would see the same thing again. So the curve, I can't point on this, sadly. Here, let's take a picture of it. Boom. And then we'll go here, and let's just drop it in. Photo recently added. Boom. Okay. We're going to add it, and then we're going to erase it. But the point is that if you, these space curves, r of t, might trace out this wire thing, in space, and that's the sort of curves that they make. So that might be one vector function. The orange one here let's change colors, might give me another vector function. And so, you'd ride it up and down and around, and pretty crazy cool. So anyway, that's the kind of graphs. It's like these thin wires stretched through space. I think we should probably get rid of this picture. Whoa. We want to come on. Delete. Okay. So anyway, vector functions are functions that look like this, and when you think about their graphs, you should think about like the little dentist toy illustration. Okay, so a couple of other details. We want to call f of t, g of t, and h of t the component functions of r of t. So these are the component functions. And then just to be very clear, we also want to think of x is f of t. If we set x as f of t, that makes sense because f of t is in the x component. We set y equal to g of t, and of course z equal to h of t. And we've sort of, just by writing it like this, you can see that I've done that. This is z, this is y, this is x. But writing it like this, these are called the parametric equations for r of t. And this should feel really familiar to you because you've done this already. Lines are examples of vector functions. But I wanted to do a little bit more interesting example with you. So we're going to see if we can figure out what this space curve or this vector function looks like. The graphs of vector functions are space curves. That's why I keep saying that. So when you want to visualize a vector function, the best way that I know is to look for relationships among the components. So let's go ahead and say that we're going to look for relationships among the components. And some of you are probably wondering, like, what on earth do you mean? Well, think with me. I know that like cosine squared plus sine squared is 1, and so that's the same thing here as saying this is the x component. X is cosine squared, y is sine squared. So I know that x squared plus y squared equals 1. And that's a cylinder. And so all of a sudden you can sort of see, okay, as x is cosine, y is sine, that's taking me around the unit circle in 2 space. And then I'm letting this z value, as t gets bigger, you climb. So somehow you're like spiraling up a cylinder. Does that make sense? The relationship between sine and cosine tells you you're on the unit cylinder. And then you realize that as t increases from 0, you spiral around that cylinder. But you're not just stuck in a circle in 2 space. This z variable is actually making you climb like that. And so we can say that this is indeed a spiral along the unit cylinder. And we might as well put an exclamation point because we're so excited. So let's switch to Mathematica, and then we're going to see the graph of this. All right, let me slide Mathematica over here. Okay, so here is our spiral, and if you look at it looking down the z-axis, you can see it's actually living on that unit cylinder. I've actually gone ahead and graphed those together to help you be able to see it. So that's the spiral that we just saw. Kind of fun. I wouldn't say memorize the equation, but I would say be familiar with it because we're going to see it again and again. So the space curve generated is this blue thread, and you can actually see how it sort of wraps around the unit cylinder. All right, let's go back to the iPad screen, and then we'll wrap up this first video. All right, back to the notes. I wanted to make a quick remark. So I said it several times, but the curve traced out by a vector function is called a space curve. Kind of a cool name if you ask me, whatever. And then I've already said this too, but lines are examples of vector functions. And just to be very clear, here's a line, r of t equals 2 plus 3t, comma, 1 plus t, comma, 1 minus 2t. This is a line, and you can see that it also fits the bill for a vector function. Space curves generated by lines, not super interesting. They're just lines. But obviously, you can get a lot more complicated. So let's end this video here, and in the next video, we'll do another example.